11.4b is solving quadratic functions or equations by factoring, specifically when a is not equal to 1. Our objective today is that I can solve quadratic equations by using the square root property, and that I can solve quadratic equations by factoring. We are going to key in on that factoring piece, and like I said in the intro, we're going to be looking at when the a value is not equal to 1. So let's take a look. Our first example here, letter A, we've got 6x squared plus 13x plus 6 is equal to 0. We want to factor that. So I'm looking for factors of 36. So if you remember back, we made these t-charts. So factors of 36 that add up to 13. Remember, this was a times c. Let's make sure that looks like an a and not a 9. A times c, and this was b. So we're looking at our 6 times 6 is 36. What factors of 36 add up to 13? So possible factors, 6 and 6 is not going to be that because that adds up to 12. 3 and 12, 3 and 12, those two values add up to 15. So we went too far. How about 4 and 9? So we're going to substitute those into the box. Some of you are going to choose to use factor by grouping. That's okay, because essentially factoring by grouping is the exact same thing as the box method. It's just laid out differently. So we substitute in, and let's just do this as a refresher. This goes in this box. Your C term goes in this box. And the factors that you find, I don't want that, I want that. The factors that you find go here and here. All right, so now we need to find what are my terms in each row and each column. So in the first column, 6x squared and 9x, my common factor is 3x. In my second column, 4x and 6, my common factor is a positive 2. In the first row, 6x squared and 4x, my common factor is 2x. In my second row, 9x and 6, my common factor is a 3. So now, normally we would write it in its factored form of 3x plus 2 and 2x plus 3, right? That's normally what we did. Well, now it's equal to 0, so now it's that zero product property that we introduced yesterday that we're going to be able to work with. So now we separate it immediately. So we do 3x plus 2 equals 0, and 2x plus 3 equals 0. My first step is going to be to subtract 2 on this one, and I'm going to get that 3x is equal to negative 2. Then we divide both sides by 3. I get that x is equal to negative 2/3. Now, my second one, I'm going to subtract 3 from both sides, and we get 2x is equal to negative 3. And then we divide that, both sides by 2, x equals negative 3 halves. So my two solutions here are negative 2/3 and negative 3 halves. All right. So now we're going to move on to letter B. Letter B is 2x squared plus 15x plus 18 is going to equal 0. So in terms of my t-chart, right, we're going to do it off to the left-hand side here. I'm looking for factors of 36 that add up to 15. So let's see, we've got 2 and 18, that adds up to 20. I have, let's go with 3 and 12, that multiplies to 36 and adds to 15. So I'm going to take those pieces. We have 3x, we have 12x, and let's just remember that our green piece, so this piece right here, the a term goes in this box. So we're going to write that in, 2x squared. And our blue piece, which is right here, is going to go in this box. And we have positive 18. So now let's do our factoring. We're going to go rows and columns. So first row, 2x squared and 3x. My common factor is x. My second row, 12x and 18. Common factor is a 6. 2x and 12x. Common factor is 2x. 3x and 18. Common factor is a 3. So we can go ahead and take these pieces and set them equal to 0. So do 2x plus 3 equals 0. My first step, subtract 3 from both sides. We get 2x equals negative 3. Divide by 2, x equals negative 3 over 2. All right, now we can use our second one. We have x plus 6 equals 0. Subtract 6 from both sides, x equals negative 6. All right, so we are factoring, and then we're setting our factors equal to 0 using the zero product property that we talked about yesterday. Reminder, that meant that two things that are multiplied by each other that are equal to 0, one or both of them needs to be 0. So we know that this could be negative 3 halves, or it could be negative 6. All right. Let's take a look at letter C. We've got 8x squared plus 10x plus 3. So we're looking for factors of 24 that add up to 10. Well, I know my factors of 24 that add up to 10 are 6x and 4x. So 6 and 4 multiply to 24, and 6 plus 4 is 10. So we have 8x squared in our first box. We have 3 in our last box. So if we look at the first column, 8x squared and 4x, common factor is 4x. Second column, 6x and 3, common factor is a 3. 8x squared and 6x, common factor is a 2x. 4x and 3, common factor is a 1. So we have 4x plus 3 equals 0. We go ahead and start solving it. We subtract 3 on both sides. 4x equals negative 3. And then we divide both sides by 4 to get x by itself, and x equals negative 3/4. Our second expression, 2x plus 1 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. X equals negative 1/2. All right, letter D, some more practice here. We're going to need to first put this into standard form. And when we do, we're going to have all of the terms on one side of our equal sign. So we're going to move everything to the left side. So I'm going to subtract 5x and subtract 3 from both sides. So it's going to be 2x squared minus 5x minus 3 equals 0. The reason why we always want these to be equal to 0 in order to apply the zero product property. Obviously, if they're not equal to 0, we can't set them equal to 0. We can't figure this out and use these properties. So that's our first step. So now I'm looking for factors of negative 6 that add up to negative 5. Well, that's going to be minus 6 and plus 1. Negative 6 and positive 1. My top left term is 2x squared. My bottom right term is minus 3. All right, so first column, 2x squared and x. My common factor is an x. My second column, negative 6x and negative 3. We have a minus 3. First row, 2x squared and negative 6, 2x. Second row, x and negative 3. That's a common factor of a 1. Right? And let's just kind of go over and do a little bit of a reminder. So the common factor of the negative sign gets pulled out here because it's in both of those two boxes. So it is common to that entire column that there's a negative sign right there. Okay, so now let's go ahead and factor these. Not factor them, we've already factored them. Let's set these equal to our 0 value. So x minus 3 equals 0. Add 3 to both sides. X is equal to 3. Now, second one, 2x plus 1 equals 0. Subtract 1. 2x equals negative 1. Divide by 2. X equals negative 1/2. Okay. Now, let's go to letter E. Notice we're doing a lot of examples for us to get some practice here. We're looking for factors of negative 16 that add up to negative 17. Sorry, factors of positive 16 that add up to negative 17. So that would be minus 16 and minus 1. All right, and we've got 8x squared there. We've got 2 right there. So we know where we're getting each of these pieces from. So now first column, 8x squared and negative x. Common factor there is an x. Second column, negative 16x and positive 2. My common factor is a negative 2. Well, why? Well, remember, on the outside, if we have a negative sign on the outside, in that position or that position, we are going to bring it to the outside of our factors, right? Because it's going to be, if it's in one of those positions, it's going to be in the third or in the corner position. And since this corner position is a positive, we know both of these values must be negative because a negative times a negative gives us a positive, right? So that's the distinction between letter D, where we had the two right-hand column values as both negative, right? It was very obvious that there was a negative sign in both of those boxes. In this one, since we're not seeing the negative sign on the 2, it might throw us off a little bit. But just keep in mind, if you see a negative sign on the outside here, you bring it to the outside, right? That's a rule we're going to follow. All right, so first row, we've got 8x squared minus 16x. Common factor is 8x. Second row, negative x and 2. Common factor was a negative 1. So now we're going to set those equal to 0. X minus 2 equals 0. We add 2 to both sides. X equals 2. We have 8x minus 1 is equal to 0. Add 1 to both sides. 8x equals 1. Divide by 8. X is equal to 1/8. I would prefer you guys to leave these as fractions, as the fraction is a more accurate answer than the decimal may be. All right. Letter F. Let's go ahead and figure this one out. 9x squared minus 30x minus 14 equals negative 39. Well, we know we need to be equal to 0, so we are going to add 39 to both sides. 39 plus negative 14 is going to give me, hold on, let me write it, 9x squared minus 30x, right? We're adding 39 to both sides. So 39 plus 14 is going to give me 25. So 9x squared minus 30x plus 25 is going to give me 0. Well, this is an odd one, but I do notice something here. My first term is a perfect square. My last term is a perfect square. And my middle term is twice their square roots. So if we were to just write this in for a moment, we're going to have minus 15x in the middles. Up top here, 9x squared. And to the right is 25. And now when I go ahead and factor this, 9x squared, negative 15x, common factor, 3x. Negative 15x and 25, common factor, negative 5. 9x squared and negative 15x, common factor, 3x. Negative 15x and 25, common factor, negative 5. This was a perfect square trinomial. So 3x minus 5 equals 0. We add 5 to both sides. We get 3x is equal to 5. We divide by 3, and x equals 5/3. And there we are. Again, specifically these kind of decimals, you must write as a fraction. Not a preferred. We're going to go with must. Write these as a fraction that's reduced. It's already reduced, but it should be a fraction because that is your most accurate answer. The answer is 5/3, not 1.67, right? Because once you round it, you've lost accuracy to your answer. All right, so let's go to the next page. And you have 4 you-try problems for you. You'll notice your last 2 are not set equal to 0, so you need to do that first before you can factor. You need to set it equal to 0. So solve these 4, letters G through J, and then check your work against mine when you're done. All right, letter G. We've got 3x squared plus 7x minus 6. So we're putting 3x squared here. We're putting minus 6 here. And we're looking for factors of negative 18 that add up to positive 7. Well, 9 times 2 is 18. 9 and negative 2 would be giving us negative 18, but adding up to positive 7. So, first column, 3x squared and negative 2. Common value, negative 2. Forgot to write the x's. Negative 2x. So common value in the first column is an x. Common value in the second column, 9x and minus 6 is going to be a 3. First row, 3x squared and 9x, common value, 3x. Negative 2x and negative 6, common value, negative 2. So, x plus 3 equals 0. We subtract 3 from both sides, x equals negative 3. We have 3x minus 2 equals 0. We add 2 to both sides. And then we divide by 3. And we get that x equals 2/3. So negative 3 and 2/3. All right, letter H. We're looking for factors of negative 14 that are going to add up to negative 5. So my factors of negative 14 that add up to negative 5, we have minus 7, and we have a positive 2x. So my first column, 7x squared and 2x, my common factor is x. My second column, negative 7x and negative 2, common factor is a negative 1. My first row, 7x squared, negative 7x, common factor, 7x. My second row, 2x and negative 2, common factor is a 2. So we're going to set this up. X minus 1 is equal to 0. We add 1 to both sides. X equals 1. My second one, we have 7x plus 2 equals 0. We subtract 2 from both sides. 7x equals negative 2. Divide by 7. X equals negative 2/7. So one thing that we can see just from these first two, if we were to have tried to solve these by graphing, would we have been able to get a very accurate answer given that we have negative 2/7 and 2/3 as our zeros? So that is one of the limitations of the graphing method, is that these precise answers are difficult to get without technology. Without having a graphing calculator or a graphing program online like Desmos, you're not able to get the accuracy and the precision that you would need to graph a problem like this. So factoring works a lot of the time. I won't say all the time because it doesn't always work, but it works a lot of the time. All right, let's look at letter I. Letter I, we need to add 23x to both sides, and we need to subtract 10. So we have 5x squared plus 23x minus 10, and that's going to equal 0. So our first term, we've got 5x squared. We have negative 10. We have factors of negative 50 that add up to 23. So you have a positive 25x and a negative 2x. First column, 5x squared minus 2x, common factor is an x. Second column, 25x and negative 10, common factor is a 5. First row, 5x squared, 25x, common factor is 5x. Second row, negative 2x, negative 10, common factor is a negative 2. So we have x plus 5 equals 0. We subtract 5 from both sides. X equals negative 5. Our second one, we have 5x minus 2 equals 0. Add 2 to both sides. 5x equals 2. Divide by 5. X is equal to 2/5. All right, letter J. We've got 5x squared equals negative 7 plus 36x. So we're going to subtract 36x from both sides, and we're going to add 7 to both sides. So we get 5x squared minus 36x plus 7 equals 0. So we've got 5x squared. We've got 7. And then we're looking for factors of 35 that add up to negative 36. So that's going to be minus 35x and minus x, or minus 1x, if you will. So 5x squared and negative x, common factor is an x. Second column, negative 35x and 7, common factor is a negative 7. First row, 5x squared and negative 35x, common factor is a 5x. And second row, negative x and 7, common factor is negative 1. So x minus 7 equals 0. We add 7 to both sides. X is going to equal 7. My second binomial, 5x minus 1 equals 0. Add 1 to both sides. We got 5x equals 1. Divide by 5. X equals 1/5. So those are our two values, 1/5 and 7. All right. So next up we have, example 7, factoring a trinomial to solve a problem. You are constructing a frame for the rectangular photo shown. You want the frame to be the same width all the way around, and the total area of the frame and the photo to be 315 square inches. What should the outer dimensions of the frame be? Well, let's look at it. Let's see, what are my sides to begin with? What are my dimensions? We've got 17 by 11, so 11 by 17 picture. We've got an X frame on the outside. So my entire width is going to be X plus 17 plus X, or 2X plus 17. What's my height going to be? X plus 11 plus X, which results in 2X plus 11. Those are my two side dimensions, right? That's that side. So it includes the frame above, the frame below, and the height of the picture. From here to here is the frame to the left, the frame to the right, and the picture. So if I'm looking for the total area to be 315, we're going to need to set this up as my first area. So 2x plus 17, right? Because the area of a rectangle is length times width, times 2x plus 11, and it's going to be equal to 315. Now, everything that we've worked has been with zero product property, which means we need to be equal to 0, which means I can't have what I see here and have it work, because it's not equal to 0, it's equal to 315, But if we move it to the other side, then we've got a subtraction thing. So it's not just something being multiplied is equal to 0. So we need to work with this, and the first thing we need to do is FOIL. So 2x times 2x is 4x squared. 2x times 11x is plus 22x. 17 times 2x is plus 34x. And 17 times 11 is plus 187. And that equals 315. My next step, combine like terms. 22x plus 34x is 56x. So we have 4x squared plus 56x plus 187 equals 315. Now, we set it equal to 0 by subtracting the 315. And I get 4x squared plus 56x minus 128 is equal to 0. Now, as I look at this, they're all even, so I know I can at least divide by 2, but I know I can divide, like 4 can divide by 4, 128 can divide by 4, and 56 can divide by 4. So my common factor is a 4, so I bring that out. Bring out my GCF. I got x squared plus 14x minus 32 equals 0. So now I'm looking for factors of negative 32 that add up to 14. So we have 4 still on the outside. We've got x minus 2. We have x plus 16, right? 16 times negative 2 is negative 32. When you add those two values together, you get positive 14. And that's equal to 0. So we set our two pieces equal to 0. So x minus 2 equals 0. Add 2 to both sides, x equals 2. X plus 16 equals 0. Subtract 16. X equals negative 16. So this goes back to the which one is our reasonable solution? What are we finding? What is x? X is the outer dimension of this picture frame. So we go back to the context that we're given, right? It is the outer dimension of the frame. It is this. That is what my x value is how wide that picture frame is. And so, does it make sense that it would be a negative number? No, it doesn't. Our units are inches, so we write inches, and we circle it. Because 2 inches is our answer for the width of our picture frame, right? So we need to go back to our context and say, what is the reasonable solution given the information we have? So the reasonable solution for this is that your picture frame is going to be 2 inches wide on each side. That will give you an area of 315 square inches. All right. You try problem. Letter B, Jason has a patio with a uniform width around the perimeter of his rectangular pool. The pool measures 22 feet by 12 feet. If the area of the pool and the patio is 504 square feet, what is the width of the patio? All right. So we need to work our way through this one again, just the same as we did the last one. In the last one, so we're going to set up, we've got 2x plus 22, right? Because it is 22 feet by 12 feet. So it's 2 times the patio width plus 22 times 2x plus 12, and that equals 504 square feet. We FOIL it. 2x times 2x is 4x squared. 2x times 12 is plus 24x. 22 times 2x is plus 44x. And 22 times 12 is plus 264. And that equals 504. Combine like terms. 4x squared plus 44 plus 24 is 68x plus 264 equals 504. subtract 504 from both sides so that we can get it equal to 0. 4x squared plus 68x minus 240 equals 0. 68, 4, and 24, those are all divisible by 4 again. So bring that out, we've got x squared plus 17x minus 60 equals 0. And when I factor that, we're looking for factors of negative 60 that add up to 17. We've got x plus 20. We have x minus 3. Which one of those is going to give me a reasonable solution? Well, x minus 20, my solution is x equals negative 20. And x minus 3, my solution is x equals 3. Which of those is the reasonable width for a walkway? It is then 3 feet. So 3 feet is your answer for this one. All right. So example 8 and 9 have you writing a quadratic function. So we're going to be given either a graph or we're going to be given 3 points, and we need to write the function based on the information that we have available to us. So the first thing we need to do is to find the factors that are related, or the factors of a related expression. Okay, so we're going to find our factors. We're going to determine whether the value of a is positive or negative, and then we're going to use another point on the graph to determine what the value of a is going to be. So let's work with this. How would we find our factors? If we remember, our factors are going to be our solutions. They are our x-intercepts. So I have a point right here at, and I'm not in the right spot, at negative 2, and I have a point at positive 6. This one is important to pay attention to the fact that your graph has a scale of 2 on it. So I know the generic form of an equation is f of x is equal to a times x, and it's going to be either minus or plus. We'll say minus x1 times x minus x2. All right, so we need to figure out what are my two solutions. So we have negative 2 and we have positive 6. So when we rewrite this, we have f of x is equal to a times negative 2, x minus negative 2, which is x plus 2, right? Because if we had x plus 2 and then we subtract 2 from both sides, it would give us negative 2, right? So we're looking at these opposites. We're looking at what would make this 0. And then we have x minus 6. So now, how are we going to possibly go about finding what our a value is? Like, I don't know how much this got stretched. Obviously, it's gotten moved, but it hasn't, like, how much has it gotten stretched? Well, let's look at this point right here. What is the value of that point? That point is 2, negative 8. I can substitute that in, can't I? I can substitute in 2 for x and negative 8 for the function, or y, and solve. So we have negative 8 is equal to a times 2 plus 2 times 2 minus 6. So we have negative 8 equals a times, what's 2 plus 2? It is 4. 2 minus 6 is negative 4. So negative 8 is equal to negative 16a. And then what do we need to do here? We need to divide by negative 16. And we get positive 1/2 is our a value. So now I just need to substitute that back in. So we've got f of x is equal to 1/2 times x plus 2 times x minus 6. If I were to FOIL that real quick, I would get x squared. We have minus 6x plus 2x, which is minus 4x, and minus 12. And if I multiply those by 1/2, I get f of x is equal to 1/2 x squared minus 2x minus 6. So on the next one, we're going to do an example on, we're going to have a little more room without the graph, and we'll be able to work with this a little bit more. We're a little less crunched. All right, let's look at letter B. Write a quadratic function for the given points -7, 0, -3, -2, and 1, 0. Well, -7, 0, and 1, 0, those give me my two solutions, right? I know those are my x-intercepts. And what is going to give me -7 as a value? It's going to be x plus 7, right? So we're going to have f of x equals a times x plus 7, right? Because if we set that equal to 0, we subtract 7 from both sides, we're equal to -7. X plus 7. Our second value, to get a positive 1, we need x minus 1. All right? And we are going to substitute in that point. Do I know anything about that point? No, I really don't. I'm just told -3, -32 is on this graph somewhere. So in the previous question, we picked the vertex because that was a nice clean point for us to work with. Could I have done something like 0, -6 on it? Sure, I could have. I wanted to make you do a little bit of work with it. I could have used 0. So that's something. But you could use any point that is on the graph as long as it's not one of our solutions, right? Because we can't use the solution as a point. Actually, mathematically, we might be able to. Anyways, we're not going to. We're going to pick another point on the graph. So we have -3, -32. So I'm going to substitute in -32 for f of x is equal to a times -3 plus 7 times -3 minus 1. So -32 equals a times -3 plus 7 is 4. -3 minus 1 is -4. -32 equals a, sorry, not a, we're going to equal 4 times 4 is -16, a, which then I divide both sides by -16, and I get that positive 2 is equal to a. So my a value is positive 2. So now we're going to substitute it back into our original problem. F of x is equal to 2 times x plus 7. I don't quite have enough room, so I'm going to shift this over a little bit. X plus 7 times x minus 1. All right, so now let's do the math. F of x is equal to, we're going to have 2 times, because we're going to FOIL this first, right? You could do this in two stages. You could either distribute 2 times x plus 7, or you could FOIL the whole thing and then multiply by 2. I'm going to FOIL the whole thing and then multiply by 2 because I'd rather multiply, deal with bigger numbers later. All right, so x times x is x squared. X times -1 is minus x. X times 7 is 7x, so that's plus 6x, and then minus 7. Okay, so that's my intermediary step there. And now I am going to multiply by 2 by everything. I'm going to distribute it, distributive property at everything, right? Think of 2 as your GCF that you factored out. So 2 times x is 2x squared. 2 times 6 is 12x. And 2 times -7 is minus 14. So we're times minus 14 there. All right. So we're going to go on. You've got two U-try problems. And then you're going to check your answers against mine. All right. Letter C, we're going to write the quadratic function for the given graph. I have zeros at -3, 0, and I have a 0 at +3, 0. So when I write my function, f of x is going to equal a times, we have x plus 3, x minus 3, right? Because we have, to get the negative value, we would need to subtract 3 from both sides. To get the positive value, we would need to add 3 to both sides. So now we are going to substitute in a third point that we know. I like this point of 0, -3. So we're going to use 0, -3 as our point. So we substitute in -3 is our y, or our function value, f of x. And that is going to equal a times 0 plus 3 times 0 minus 3. Zero plus 3 is 3. 0 minus 3 is -3. So -3 equals a times, sorry, not a. We're going to lead with -9a. And then we divide by -9. And we get -3 over -9 is a positive 1/3 is equal to a. So when we substitute that back in at the top, f of x equals 1/3 times x plus 3, x minus 3. Well, x plus 3 times x minus 3, that gets me x squared minus 9, right? That's one of our special cases. So you get f of x equals 1/3 times x squared minus 9. And then when we multiply that 1/3 out, f of x is going to equal 1/3 x minus 3. Okay. And now for our last one, we're going to write a quadratic function for the equation. For the given points, we have -8, 0, we have 0, -8, and we have 1/2, 0 as our third point. So these are my two solutions, not my solutions. -8, 0, and 1/2, 0 are my two solutions. So we need to write our expressions. So we have f of x is equal to a times x plus 8 and x minus 0.5. Do we normally have decimals in there? No, but we can use it to, in this case, to manipulate what we have into what we need. So now we're going to substitute in 0, -8 as our y-intercept. So we substitute in -8 is equal to a times 0 plus 8 times 0 minus 0.5. And I get -8 is equal to a times 0 plus 8 is 8. 0 minus 0.5 is -0.5. When I multiply, -8 is equal to 8 times -0.5 is -4a. And then we divide both sides by -4. And we get that 2 is equal to a. So now we have f of x equals 2 times x plus 8 times x minus 0.5. So f of x is going to be equal to So we've got x times x is x squared. We have minus 0.5x plus 8x, so that's plus 7.5x. And then 8 times negative 5 is minus 4. And then we need to just lastly multiply that 2. We distribute that 2 to everything, and we get f of x is equal to 2x squared plus 15x minus 4. All right. And if you ever want to check your work on these, you certainly can by taking 2x squared plus 15x plus or minus 4 and factoring it. So you're looking for factors of negative 8 that add up to 15 potentially. Find what you've got and go from there. All right. These are the end of our notes for today. If you have any questions, please bring them to class. Otherwise, I hope you have a great day. Take care.